Good evening, everybody, and welcome to another episode of vBrownBag. This week, I am excited to announce that we've got Vincent Ramirez. However you prefer to be called.
Yeah, thank you. I go by Vinnie.
Vinnie. All right, Vinnie. And tonight we're going to be talking about, he works for HashiCorp, and we're going to be talking about the Cisco Intersight Service for HashiCorp Terraform. So we're going to get our infrastructure as code learn on. But before we do that, a couple of house notes. If you want to get in on the conversation, we are at vBrownBag on Twitter. I'll be watching the feed to make sure that any questions that you have will be answered as we proceed. And if you also want to, or you can do the hashtag vBrownBag, and I will also be paying attention to that. For attendees in the live studio audience, you put your questions into the Q&A panel, and I'll be fielding them from there and asking them of Vinnie. So with that, normally we have either one or two other co-hosts with me, so it feels weird to not have them on. Okay. Ziggy is traveling in Alaska right now, and Sean is having an electrician gut his house. So they are both down for the count.
All right, no problem.
So with that, I will turn over the power to you, Vinnie.
Yeah, thank you. Let me share my screen and I'll introduce what I've prepared to present today. And right, if you're able to just confirm the screen share, everything good there? Screen. All right, perfect. Okay, so today I'm going to go ahead and present some information about a recent partnership that was formed between Cisco and HashiCorp, and the integration that's been formed is known as the Cisco Intersight Service for HashiCorp Terraform. So we'll learn all about that. And the real quick agenda of this presentation, I'll introduce myself. We'll take a look at HashiCorp Terraform, the open source solution, and a quick overview of that for anybody that may be new to the solution. Then we're going to build on that with the Terraform Cloud solution and take a look at some of the problems that solves and some of the features that are introduced with that. And then we'll get to the Intersight service for HashiCorp Terraform, which is a combination of our commercial offering of the Terraform solution and the Intersight solution from Cisco, and try to save some time for Q&A and point you to some resources for more information when I'm done. So I don't have an intro slide, but I'm Vinnie Ramirez. I'm a solution engineer at HashiCorp. I've been with the company for 3 years now, and I've worked in our field sales organization, supporting some large accounts on different solutions at HashiCorp, Terraform being one of them. And more recently, towards the beginning of the year, I was asked to work directly with Cisco to kind of sort through this partnership. And I focus more on the technical sales enablement side of this, and because this is a commercial offering, supporting sales cycles and things like that with customers that want to enter into a commercial relationship with HashiCorp to explore the IST offering. So that's sort of who I am, but I'll try not to sound like a salesperson here this evening. So
that's important. At vBrownBag, we do not allow commercials.
Okay,
so we'll turn the whole thing off.
All right. So yeah, definitely not gonna tell you about, like, an end of the year sale or anything like that. So
10% off. What?
Right. All right. So real quick on Terraform, it's a solution that lives in this problem statement world of the fact that our world has changed drastically with the onset of public clouds, and really kind of the DevOps movement and this notion of infrastructure as code. And really what we saw is most of the major public clouds have their own infrastructure as code tooling, but those tools have historically been native to that cloud platform, so limited in their reach in terms of they can only control services that live in a particular cloud platform. And with that, we've kind of got the traditional IT journey that most large enterprises have been on since before public clouds, and all of the technologies that exist in a private data center, each of which have their own UIs or CLI tools and things like that were used historically to provision and configure those solutions even before the DevOps movement and infrastructure as code existed. So that's really the world we live in for people that aren't born in the cloud and cloud native. And that's really where Terraform came along, kind of starting with the multi-cloud problem statement of saying, this is great, I want to be able to deploy and configure resources in public clouds, but I'm not just working in one particular cloud maybe. And so what Terraform introduced was a standardized workflow and a tool that's built on this notion of providers. And what a provider is, you can think of it as a plugin that's able to consume a technology's API and really abstract that and simplify it so that you can codify in a declarative way, create configurations to do things against this provider network, some of which are represented in this slide, but it's a very vast network that's continually growing with participation from all sorts of vendors. All right, real quick on what does that mean in terms of the use of Terraform, our open source solution, which is freely downloadable. So I have a quick build just to illustrate for anybody that may be new to this technology, what this workflow I'm talking about is. And if there are questions or anything along the way, I mean, there's breaking points, so we can definitely do that. I just want to get through this one here. So a very common beginning experience that people have with HashiCorp is to say, just pick up your laptop, get on a Cloud Guru or Udemy or something and start to like learn how to use this tool. You can do that by downloading it for free, either in a compiled version to run on your favorite operating system. And what Terraform is it's a command line utility. And to use it, you're going to write some Terraform configs or find some examples out on the internet. There's tons of examples out there, pre-authored Terraform configurations that do things against different cloud platforms or private data center technologies. And what you'll do is you'll create a working directory on, in this example, a laptop. And what you'll have is a handful of these configuration files that are necessary to have the tool do something on your behalf. The next step here, once you have some configurations written, is to initialize the Terraform open source tool. And there's a command, Terraform Init command. When you run that, it does a couple of things. It will check the syntax of your Terraform config files, make sure that there's no syntactical errors that are going to prevent it from parsing those files that you've handed to it. And additionally, it's going to look at any providers that have been defined in those configurations. And then it will attempt to reach out to, more commonly, this public location where it can find those providers, which would be the registry terraform.io location. And providers all map out to GitHub repositories effectively. So these are public-facing provider code snippets that it will go and bring down a local copy of. It's important to note, though, that we do support the use of, say, a privately hosted provider as well if you're operating in an air-gapped environment that doesn't have public internet access and things like that. So very, very broad use of the tool is supported. Once you do that, the next thing would be to enter this next phase of using Terraform, which would be to do a Terraform plan. And when you pass that command to our tool, what it's going to do is take the files, the configuration files that you've handed to it, and it's going to talk to the API endpoint of the providers that are defined and do a dry run as described. And what that dry run does is says, maybe you're trying to spin up some EC2 instances in a public cloud or a Kubernetes cluster on premise with a provider that allows you to do that. It will run through the API calls, get the outputs of those, and it'll spit them back out to you as an output. And you'll be able to see, without actually taking action and deploying things, you're about to do XYZ thing. This will result in 5 resources being deployed into your AWS account or your on-premise vCenter, whatever the case may be. You'll get that information back, but it's not actually doing it yet. So that's the dry run phase. And then along that, the next step would be, if you're okay with everything, this is exactly what you wanted to do. The next phase would be a Terraform Apply. And when you pass that command, this is an actionable command, and Terraform will reach out to a public cloud provider or a scheduler or some private data center technology or third-party solution running in a public cloud, whatever the provider supports, and it will take that action on your behalf in a declarative manner. So what that does is it will work out and orchestrate the steps necessary to configure and deploy the resources as you defined. And the end result is what's known as a state file. And that is a JSON blob output of whatever that target endpoint reported back from its API that you asked it to do. So that is our Terraform open source workflow. And I'll pause for a second. Not sure if that sparked any questions or anything around how Terraform works in its raw form.
No questions yet. No, we're good.
All right, perfect.
So a lot of, I mean, I'm not going to speak for for a lot of the folks, but I'm going to say that we have a good blend of IT administrators that are, Terraform certified and stuff. So, but this is going to be great for like new people that are watching the video for the first time and getting their feet wet. So check out the download links that he's provided right there, and definitely check. There's a plethora of training videos out there that can run you through the basics.
Yeah, absolutely. And at the end of the presentation, there's some sort of like next steps links that I can share as well too.
Awesome. We'll put those in the show notes too.
Yeah. So the Terraform downloads link is really just to get a particular version of our CLI tool, and then making reference to our registry, which is where we host things like providers that either have been endorsed by HashiCorp, or it's become just kind of the common place for any vendor that wants to write their own, or even just any community member for that matter, to write a provider that does a thing and put it there for everybody to use. So that's kind of the power of Terraform. On that note is and it's open source. It's very collaborative and community driven. If there's a problem per se with a provider in a particular technology, you can also learn to modify and enhance an existing provider, and in true modern developer practice, submit a pull request if you've solved some issue with a provider, and add back to that experience of the users of that provider. So that's sort of the birth of Terraform and its history, right? And so we're going to build on the fact that here's the open source experience. If you just want to use Terraform, freeware version, right? No need to contact sales or anything to get a hold of the technology, and away you go. So there are some considerations though when it comes to the use of open source, which will kind of move us into our commercial offerings and what those exist to solve. So building on that workflow that I just introduced, again, Terraform is a command line utility. For it to execute on your behalf, you need to give it access keys or privileged credentials, depending on the technology that you're trying to control with Terraform. This can be problematic, obviously, in the fact that our open source tool does not solve for this in and of itself. And the way to provide those keys and access that Terraform needs to do its job tend to be things like, in the laptop use case, setting secrets as an environment variable in the operating system, or hard coding them into another config file that you reference, and then maybe just add to your like git ignore when you're storing your code and things like that. Another thing to be aware of is that state file that I mentioned, which is a plain text JSON blob of all of the outputs you got back from whatever provider technology you were using Terraform against. And state files contain sensitive data, and they need to be protected, and our open source solution does not inherently support collaboration of state files as well. There's a couple additional steps that you'll need to do as an open source user to be able to work, say, in a small team setting and collaborate on the same set of infrastructure that Terraform's controlling. And sort of the last thing to be aware of is it's a command line tool. So that means that it does not actually have an API in the open source version. And so if you are, a heavy automator, there will be this need to either manually execute Terraform or script that through the use of your favorite scripting language, or wrap it in another process like a CI/CD runner or something like that that can trigger your Terraform commands for you. So what this then leads to is very common workarounds that we see in sort of this pattern to take this open source tool and maybe scale it a little bit further than what it was intended for in, the individual user use case that you would find as an open source user. So some of the things that I'm talking about would be, instead of running it on your laptop, maybe a dedicated virtual machine or a container is stood up, and you'll limit access to a small team. And of course, start to store and collaborate your configuration files in a version control system instead of just storing them in your working directory on that VM or container, things like that. And then, wrapping the execution of Terraform commands or scripting them in some way is definitely a popular direction to head. In the open source workaround world, I've yet to see a common answer to the management of secrets and access keys or the privileged access necessary to allow Terraform to execute against your operating platforms. And so that's when you kind of peel back the onion of people sort of wrapping things and processes around the open source, this tends to always be a problem that's never really solved in an elegant way or in a standardized way. And the last thing here was that state file. Our open source solution does have support for a number of storage locations that you can integrate with the open source solution. Object storage is a very common one, like S3 buckets and things like that. But with that, you could end up with state being stored in multiple locations, and you still have to make sure that if you are using an object store in, say, a public cloud, that you configured that correctly with access controls and things like that, encryption, prevented it from being exposed publicly and all of those things. It's all sort of onus on you. So what this all kind of nets out to, and this kind of story I'm painting here, is the open source solution is great. And there's a lot of advantages that you can grab the tool, quickly scale, learn as an individual to master it, write Terraform, specialize in a particular cloud platform or technology, that sort of thing. But it doesn't really scale when you start to bring it into the workplace, is the message we really like to just put out there so that people can make an informed decision around how far to take the pure open source tool. So in this scenario, I've got 3 different development teams illustrated, and let's say they're all working for the same company, and they've all come to choose Terraform on their own and sort of in their own bubbles, right? So a very typical phenomena we'll see is each of these teams will embark on their own Terraform journey and make some decisions around how they use Terraform open source in the workplace. The first example here would be sort of that traditional laptop user, right? Just saying, hey, this is easy enough. We'll just put it on our laptop and we'll save all our configs and fire away from our laptops. Obviously not safe for production workloads, and kind of a scary posture if you're not using a version control system to save off your Terraform configs, and if you haven't addressed where you're going to store your state and how you're going to manage your access keys and things like that. But, it's not all doom and gloom. If this is some, new team that's forming and they're not doing production work, right? I mean, this could be a great solution just to get going, get moving with the tool, learn it, master it kind of thing. It's just more of the caution around once things turn real and get critical for your organization, maybe question this pattern. And then the next one here would be Team Y, that is kind of taking that road of saying, all right, let's devote a virtual machine or a container or something that our team has access to, and we'll take turns hopping into this system and executing either manually or via scripted means the execution of Terraform, but we'll do it all from this one particular box or VM or container. And there's still sort of the same problems there too, right? This is now something that just this team uses, and they still have sort of the same issues they're introducing: secrets management, how they collaborate with version control system, and whether or not the decisions they're making are standards that the company wants to adhere to and follow. And sort of the last example here of Team Z is, maybe this is the more progressive team that's building pipelines and using like CI/CD tools. And what's kind of a common pattern is to bake the Terraform command line open source utility into, say, a runner in a tool like GitLab, for instance. Then your CI/CD tool can trigger some deployment actions as part of a comprehensive pipeline. Terraform gets executed, pipe off the state files to an object store and start to consume it that way. And sort of the note of caution there too is that this is still going to have some of the same problems that the other methods had around secrets management and potential introduction of non-standard tools. So how you manage those secrets, or even using maybe a CI/CD tool that's not endorsed by the greater organization, or you're the only team that knows how to build and use a pipeline and no one else can really jump on board with that. So it's really kind of the picture we're painting here. And when it comes to this discussion around like these custom processes or homegrown solutions that each team may choose to adopt, in a large organization, what this really nets out to is security and compliance teams don't like custom stuff, right? It's puts them kind of in a bad place to come through and do like a company-wide audit or have visibility into what is, what's really happening across the teams, who has access to the cloud subscriptions, who has access to, third-party solution access keys to use Terraform. Things like that would be a very hard and challenging question to ask from an auditor when you have teams just sort of doing their own thing with the open source. So that's sort of the message there. And we also have seen instances where some teams have been very successful at using Terraform and kind of flown under the radar for some time. And eventually the security and compliance teams catch up with them. And that can also result in shutting down projects and things like that, because people become uncomfortable with how this is architected, how secrets are being handled, who has access to Terraform and its state and all of those things. So that's sort of just the soapbox message here around some of the considerations and really some of the tipping points of when to consider a commercial offering of Terraform versus continued open source use. So as far as commercial offerings go, that's going to bring us to our Terraform Cloud solution. And what I've got here is just kind of a visual representation I put together to explain some of the elements. If you were to crack open the hood, Terraform Cloud is actually a SaaS offering. So that what that looks like is HashiCorp manages some compute, which is devoted to Terraform activities. And there's a couple things we do. We handle secrets management by integrating our Vault secrets management solution. But this integration is baked into the solution, and you're not in any way like a Vault direct user. It's used to encrypt data that's marked sensitive. It's used to encrypt our the state files that are created before they're even committed to an object store. And any sensitive data will run through our solution as the encryption engine. And we integrate with a dedicated database for any metadata to track the historical runs and use of Terraform over time. And we'll integrate with an object store. And like I said, we'll encrypt everything before it even hits it. And this concept over here to the right then is what we call this concept of a runner. So what we'll do then is when you have work for Terraform to conduct, so a plan and apply known as a run, we'll spin up these ephemeral runners just in time. So when you're ready to deploy something or have Terraform take action for you, this controlled compute will then spin up a ephemeral container or a VM with the particular version of Terraform that you want to operate on. We'll conduct that run and we'll scrape the outputs and store them off. So the state file, the history of the fact that on this day and time, somebody did something with Terraform, and then we trash that runner. We don't keep it around. It's destroyed, and then its outputs are preserved. There's other elements here too, like we have integration now natively with the most popular version control systems out there. We support some of their workflows, and then there is this capability within our commercial offering of Terraform known as Sentinel, which is a policy as code capability where you can translate like business or security logic enforce it programmatically. So things like change windows that can only happen between certain days and times. If you try to operate outside of that, you can shut it down. Ingress egress rules that are allowed or not allowed for firewall settings or gateway settings and things like that. So that's kind of at a glance what we're talking about. And our commercial offering does have an API. So we're no longer scripting things. We can directly interact with an API, and the commercial solution also has enterprise grade SLAs. So we're responsible for the uptime of this platform, and there's different tiers that it's available at to support your operational needs. All right, mouthful there, but we also introduced some, I guess it's fair to say, like opinionated concepts of how to use Terraform in our commercial offering. So some of those are, we have a role-based access control model that leverages like the concept of users, groups, and tokens that can all be modified and tuned to support the principle of least privilege and things like that across your users of the platform. A high-level construct for us is known as an organization that can share a couple of things. One is a privately hosted module registry, where you can reference pre-authored Terraform code and make it easy to consume, and know that that code has been put through, say, your own internal review process, and people agree that this is a best practice way of doing something in your organization. Those Sentinel policies I referred to are also shared at the organizational level. And then these things start to get consumed by these units of measure known as workspaces in our commercial offering. So for open source users of Terraform, the term workspace is a little different in our commercial offering. And by that, I mean, it's not just a directory flagging type of model that it is in the open source, where you would say workspace - name a workspace as part of your command. A workspace is actually a uniquely identified unit of measure that maps to a single set of code that's either programmatically uploaded to the platform or through a version control system integration linked to a workspace. So that's one way of trying to explain it. And then that's where we attach a lot of some of the other features that we have, like secure variable storage, state file collaboration, being able to see like the run history and state history of anything that this workspace has done over its life and things like that. So hopefully that helps introduce conceptually some of what this offering does. So we're here to talk about Cisco Intersight. And so don't want to make assumptions there either, but over time, Cisco has been sort of moving traditional on-premise operational tools, things that like Phone Home and Heartbeat and things like that, and into their SaaS offering known as Intersight. And then they've also been starting to layer onto that kind of a suite of different software capabilities now that they have this SaaS platform known as Intersight. And some of those capabilities are things like their Intersight Cloud Orchestrator solution, which kind of stitches together like third-party technologies that Cisco partners with. And they have their workload optimizer offering, which is basically like a white labeled Turbonomic, or kind of an OEM version of Turbonomic that they partnered with to bring under the fold of their SaaS offering. And along with that, you can see here, they have this, these are like their modular concepts of the Intersight service that you can kind of a la carte build together depending on where you're at with your Cisco journey and some of the capabilities that their platform offers. And this is where you'll find the Intersight service for HashiCorp. It's a modular approach, and it's a capability that you can turn on as an Intersight user. And what it essentially does is, it will interact with Terraform Cloud through this integration. And I'm going to unpack that really quickly here architecturally. So here's a quick representation of Terraform Cloud sort of by itself, right? No integration yet. I mentioned that concept of a cloud runner or an ephemeral runner in that first sort of architectural diagram of the platform. So think of this as, a VM or a container running whatever version of Terraform you need it to be at on infrastructure that the Terraform Cloud Platform controls. A very common workflow for us is the use of version control systems. So developers can write their application code as well as their infrastructure code, check it into a repo, and we have the ability to then map that in our platform to a workspace that listens for change. So once some Terraform code is committed, that can trigger an event which says, okay, I've given you some Terraform code, go ahead and run it and execute it, as long as you've provided the access to do so, subscriptions to a public cloud. This cloud runner will reach out to the APIs that are exposed publicly by the major cloud providers. And this is kind of a very comfortable mode of operation for public cloud users, because we basically understand that when AWS or Microsoft or Google exposes their public cloud endpoints, they're also responsible for protecting those from like DDoS and spoofing and other things like that. So allowing our SaaS platform to talk to a major cloud, this is something that, you know, cloud native folks are typically very comfortable doing. And most people are okay with this and would much rather use our platform versus running on a laptop or managing some jump box that hosts Terraform at a particular version and all of that. So the next type of workflow then that comes in would be, I'm not just operating in a public cloud, I have a private data center that has technologies in the various domains that I need to control as well with Terraform. To do that as just a Terraform cloud user, well, that's a little problematic, because the ask back to the customer is, go ahead and Swiss cheese your firewall and expose all of your control plane APIs to our SaaS platform or publicly so that this runner can find them. And this was in the first iteration of Terraform Cloud, something that was not in any way embraced by enterprises. And they said,
you mean people would have a problem with that? I don't see why. It's so weird.
They did, surprisingly. And you know, for obvious reasons, just when you start to look at that conceptually, do you really want your vCenter just, you know, publicly exposed to the dirty internet, et cetera, right? So really, when we first introduced Terraform Cloud, it kind of fit this world of, you know, the public cloud users who really saw the advantage of just working in their version control system. If Terraform needs to do something, it does it, you know, it's off in the cloud. It's easy to consume, then I don't have to worry about it. So to address this lower right corner here, the private data center, right, and API endpoints that we would like to use Terraform with, but don't have the ability to reach because they're on private networks, we introduced another version of our Terraform Cloud offering, or another tier, which we call Terraform Cloud Business. And there were a number of things that it introduced to support enterprises, things like SSO and like known CIDR ranges that you could attach to if you are doing firewall rules and things like that. But one of the main technologies or features of this solution that we introduced was this notion of a cloud agent. So if you look here in the data center, it's the similar concept to a cloud runner, where we need the ability to, on infrastructure living in a private data center, run Terraform, okay? And so the way our Terraform Cloud Business first introduced and solved this problem said, we have this idea of a cloud agent. It's a Docker container. Go ahead and host it on the infrastructure of your choice, whether that's some clustered VMs, a scheduler, et cetera. We'll give you this agent method, or this Docker method, this container method. And what you'll then do is, you're not going to Swiss cheese your firewall. You're just going to punch out over 443 and start to an outbound polling of our SaaS control plane. And from there, there's this agent pool now that will be able to listen for anything that comes through and says, hey, I've written some Terraform. but this is Terraform that needs to be executed behind the firewall. And we'll pick that up, send the job to the cloud agent that's subscribing and listening to that bus. And it will now be able to provision behind the firewall as long as there's a Terraform provider to support the technology you're trying to control with Terraform. So that was Terraform Cloud Business. We still haven't got to the Cisco piece of it yet, but just want to make sure that that next step of the architecture makes sense. And really, we're building off cloud agents now that live behind the firewall.
Quick question.
Yeah, go ahead.
So sorry, the providers are in the data center. These aren't. Was this what you were referring to as not Swiss cheesing the firewall?
Yeah. So if you notice now, we have a cloud agent, which is a similar behavior here. Mm-hmm. Here, there's Terraform being run on, say, like a container.
Sure.
In our SaaS platform, and it needs to deploy into AWS or whatever, then we don't really care that that container is on infrastructure that HashiCorp controls, because it's destined to some endpoint that's publicly accessible.
Right.
In this model here, we'll say this compute API is the vCenter, mm-hmm. and there's a Terraform provider for vCenter, but I'm not going to expose vCenter to this agent here, this cloud runner. Mm-hmm. I'm going to allow a local copy of Terraform running. Yeah, so the provider as well. There's a couple of ways to do that too. The provider can be bundled up and sent, with the workload onto this. Okay,
yeah, that's what I was asking. Okay,
all right, yep, no problem. But yeah, there's a number of ways to skin that, right? But effectively, what I'm trying to illustrate here is that whatever compute solution, storage, network security solution, if there's a Terraform provider for it, there's a way to do this, right? It's just, there's a way to do it behind the firewall. And it's basically because of that cloud agent. So when we look at Intersight now, which is, it introduces now support for 2 different workflows that should be, fairly relevant to a enterprise customer that's operating in public cloud, private data center, and is a Cisco customer. So in this scenario, the first workflow we support is what I'm referring to as a Sas Sas Workflow. So the Intersight solution itself has a Terraform provider. So in that world, I can use the Terraform Cloud hosted runner, execute against Cisco's API using the Intersight provider, because Cisco's Intersight API is publicly accessible, the same way that a public cloud's API is accessible. And so if I then need to deploy some infrastructure via the Intersight API and its capability and integrations to do things like deploy VMs, configure a UCS server from the ground up, deploy a Kubernetes cluster, whatever the case may be, if the Intersight provider has that capability, I can do it, and I can do it SaaS to SaaS. It's the model. There's no real concern yet about that firewall boundary yet. So that's the first workflow that we'll support with this integration. And then the next one is this notion of a SaaS to agent workflow. So the Intersight solution has a on-premise footprint, which is their Assist appliance that, it's a set of VMs that gets deployed behind the firewall, and it establishes communication back to the Intersight control plane. So our integration is actually leveraging some automation where the Intersight solution will instantiate our cloud agents on behalf of an Intersight customer. And it's going to then establish communication back to the Terraform cloud control plane so that it can subscribe to that agent pool and listen for work. So why would you do this? This Assist appliance as an Intersight customer is sort of like that one-stop shop to create all your networking trusts and rules across that private network to say, let's just open up the Assist appliance to be able to talk to all of these different technologies that live in the private data center. Once you've done that, Terraform can take advantage of writing all of that now. So again, if there's a Terraform provider to support the technologies in the private data center, we can do that with this cloud agent running on the Assist appliance instead of on your own infrastructure. So it's sort of like a consolidation of having to stand up more pockets of infrastructure to run yet another tool behind the firewall. As an Intersight customer, you will need to deploy this Assist appliance anyway. So taking advantage of the fact that it's already there is our integration point to then put the cloud agent behind the firewall. And there's some other added advantages where the lifecycle management of latest and greatest versions and things like that of this Assist appliance are managed by Cisco, as well as they'll manage the lifecycle of our cloud agents when those need to be updated and things like that. So it simplifies the integration between the two solutions. And really the power is now coming back to this end consumer, right? It's saying, you know how to use Terraform, you use it today in public cloud workflows. We want to give you that same experience to be able to deploy and consume infrastructure and your applications behind the firewall. And as a Cisco customer, we're providing a path for these traditional private data center folks to start to support that modern developer, modern infrastructure as code user in a way that isn't disruptive to them, right? They don't have to come and advocate and go to the security team and fight, for the right to deploy these cloud agents. If, the Intersight and Cisco team that already uses Cisco solutions wants to deploy in this method, there's a lot of advantages to doing that and kind of reduce barrier to entry to get that Terraform reach behind the firewall. So I'll pause and see if that sparked any questions or comments from you there.
Checking the feeds. Nope, we're good.
All right, perfect. So that's kind of the heavy lift of the presentation, but effectively, it's a little confusing if you haven't seen like Terraform Cloud explained conceptually this way. So I hope I did a good job of kind of simplifying the architecture with these drawings. But
yeah,
key thing is you can go cloud to cloud or SaaS to SaaS, right? Our SaaS offering directly to a public cloud, most people are comfortable doing that. And most people would be comfortable talking directly to the Intersight API using the Terraform provider for Intersight if you already are an Intersight customer. The need to go behind the firewall now is more, if there's automation you need to perform that Intersight doesn't have yet or isn't able to do, you might need to go direct with Terraform to whatever solution it is that you need to automate. And so now you kind of have the best of both worlds in this model as a Cisco user. Those use cases can range from, basic IaaS consumption to more complex things like last mile network infrastructure automation. You've deployed applications, but if you can't automate an ACI PBR associated with it, or configuring a firewall even to allow traffic for that application or microservice that you've just spawned behind the firewall, you're ultimately going to wind up then opening a ticket or something, and you've lost all of the advantages of infrastructure as code and being agile as a DevOps developer at that point. So trying to extend the reach and that experience that you come to know and love in a public cloud behind the firewall. And there's a number of areas where, outwardly that sounds scary, right? Like, I don't think so. You're not going to configure my firewall, but we have that policy as code engine, and there's some guardrails that can be put in place to programmatically enforce. Only certain behavior is allowed. If people try to go around that, Terraform can shut it down and make sure that as you give people freedom and self-service capability for private data center resources, there's ways to control that they don't get abused or people don't use them in, an unsecure or non-sanctioned manner. So those are some of the things we're up to there.
Okay. And when you're talking about the policy as code, you're referring to Sentinel, right?
Yeah, absolutely. And potentially, there's also, that can get confusing when you use the term policy in the same sentence as Cisco, because they also have policies, right? So yes, I was referring to HashiCorp Sentinel policies specific to Terraform, but Intersight itself and a number of the Cisco solutions also have policy concepts as well too. So between the two, there's a lot of postures that can be codified and put in place to agree upon. Here's the things we will allow people to self-service and do in a safe manner. The last thing I was going to just quickly hit on was who is this for, right? Because this gets a little fuzzy when you start to look at sort of the traditional users of Cisco solutions versus the public cloud modern developers of the world. So sort of tell this story in 3 personas. On the far left here would be your modern developer or the traditional infrastructure as code consumer persona. And these are people that use Terraform today and have used it potentially for years now against public cloud platforms. And this solution is for them. These are your cloud native, automation driven, agile developer folks. A solution for them if they're given the task of deploying applications that need to live behind a firewall in a private data center at an edge location, something outside of just your standard public cloud platform. And we're starting to see a lot more of this in large enterprises that are operating in hybrid environments, that challenge to bring the modern development experience behind the firewall where historically things have been very slow to roll, or this concept of mutability has historically dominated the landscape of a private data center versus immutable consumption of a private data center resource. So just deploying something just in time, maybe a very short-lived infrastructure that whenever a change is needed, you destroy it and redeploy it with a workflow like Terraform. Mm-hmm. So the solution is definitely for the modern developer, but think more being tasked with deploying behind the firewall in a private data center setting. The middle folks here are your traditional operations folks. So think of people who manage physical servers, hypervisor admins, storage admins, those folks. This is in all transparency, probably an audience that may not actually consume infrastructure as code as much as just needs to be aware if it's being used against their solutions. So the comment I made about mutable versus immutable, if you're a VMware admin, all of a sudden you see a bunch of VMs spawning and living for a couple of minutes and dropping, and that's not behavior you're used to seeing because
you might get a little concernicus.
Exactly right. That could be concerning, and you've got like a CI/CD pipeline that's consuming your vCenter, and so there's education that obviously would need to take place, and those are also like collaboration points for these folks to say, all right, if the nature of this workload is going to be that chatty and that ephemeral, let's carve off some data centers and some VLANs or whatever, and here you go. You guys can just chew through these, that whole concept, right? So, but they won't. We're not necessarily saying like you need to scrap all of your traditional automation tooling and retrofit to do everything with Terraform, because that doesn't necessarily make sense for certain on-premise administrative tasks. And then on the far right, this is another emerging group here where our traditional networking folks have been pushed into hybrid networking topologies now, direct connects from on-premise networks and stretching fabrics into public clouds. And there's a lot of initiatives now in the network infrastructure automation space that we're seeing in private data centers. And these folks here, your traditional, like Cisco admins, if you will, right? And your like SD-WAN admins and network architects. These folks actually would represent probably a user of Terraform for some of their initiatives in certain parts of their stack that it makes sense to create modules to dynamically configure some of their solutions, and also need to be aware of a consumer of their network service. So there's sort of a little bit of both going on there, where to do their day job, these network admins and network operators may have initiatives where they want to codify a lot of the things that they do on a daily basis for their own operational tasks. And then yet they'll also have, the audience here on the far left that says, I just need to consume, a Kubernetes cluster, but once my workload spawns, I need, my ingress gateway to be registered dynamically with your ACI solution or that firewall that sits between the on-prem and the public cloud I'm trying to target, or whatever the case may be. Right. So kind of a mouthful there, but it's one of these technologies. Terraform has historically been a technology that kind of breaks down the traditional silos and these siloed modes of operating and starts to kind of bring people together, right? If you have an on-premise initiative to support modern development, infrastructure as code, bring everybody to the table, and at a minimum, make sure that everybody's very well informed that it is a tool of choice. There will be certain behavior that will look different when a Terraform user is consuming your technology versus a mutable, deploy it, care and feed it for several years type of workload. And with that, I think we're right at any questions or anything I can help answer.
Hold on, let me scour the Twitter sphere, make sure that. So there was one earlier question about secrets.
Sure.
It wasn't related to the Cisco bit, so I held off on it for a little bit. It was a question about Vault and its integration with. Does Vault integrate with public cloud native secrets managers?
Yeah, that's a good question. So
it was complete. I mean, you said Vault, so it counts.
Yeah. So all right, so that is a little out of topic for this particular presentation.
Yeah,
but
it was very off the wall. Sorry.
But we more recently have started to introduce this. If you think of Vault being able to sync with a cloud native key management service. So that is something we're starting to introduce. Off the top of my head, I want to say I'm pretty sure we can do that with Azure today. I'd have to look at which clouds we support with that type of integration. But conceptually, what you would be doing is Vault would serve as your source of identity, your identification broker. And you would effectively you'd have a workflow where you write secrets into Vault, and it can then also commit them to a key management service in a public cloud as, say, the storage target for it. But through that ingestion of the secret, Vault becomes aware of it and in control of its life cycle, even if it lives in the key management service in the public cloud. Versus if you went directly to it, if you went directly to the KMS service, then Vault would be unaware of the secret at that point. So that's a good question, and it's a kind of a newer capability that we've been introducing with Vault recently.
Yeah, normally if a question is too far out there, I just ignore it and I say go Google it. But
Right.
you actually did say the name Vault, so I figured. Okay,
yeah.
Well.
Fair game. I said the word HashiCorp, so that typically opens up anything at that point.
All right, let's get into no. Cool. Okay. So that was it. Actually, so in the audience we have a member of Cloud Field Day. And Nate has been suspiciously quiet, so I'm not gonna unmute him unless he wants me to. But so Cloud Field Day is one of the places where actually me and Kyle Ruddy and a couple of other folks over at HashiCorp met, and we've jived on things. And Ned Bellavance, the guy that does Terraform Tuesdays on YouTube. He's one of the Cloud Field Day shenanigan doers.
Okay,
So,
awesome.
So when Nate jumped in, I was like, oh, let's see if Nate has some questions. But he's been kind of quiet. You inspired me to. Nate said you inspired me to install TF on my new laptop. Okay, so he's working on a laptop right now.
All right. Well, thanks for attending today, Nate. And we definitely appreciate all of the opportunities to come and participate in these forums, right? Talk about what we're doing. We actually, we do get a lot of coverage on things we do in the open source. So it's also good to be able to, attend events like yours today and talk about a little bit on the commercial side of things, right? For
absolutely,
folks that do have a day job, right? And we want to just get the word out on some of what we're doing, and more so, just sort of that cautionary, voice of reason, right? Just with anything, with great power comes great responsibility, right? So Terraform is kind of like a Spider-Man. It has a lot of power.
And you're Uncle Ben. Awesome.
Yes. So I don't know that I'm Uncle Ben, but yeah. But yeah, if there's any other questions, hopefully this was helpful. It's actually, kind of just a repeat content-wise of you mentioned Kyle. We recently did a webinar last week on the same topic.
Oh,
Kyle Ruddy and I, yeah. So similar information, but yeah, if there's any other questions about anything, you guys have me. I'm happy to attempt.
Actually, Nate just did pop up with a question. He's asking about the adoption rate with network folks. Seeing as how network folks tend to be a little bit more resistant to change, because that's how they go. Are you seeing how are network folks receiving this?
Yeah, so it's interesting because there's two worlds where we're living, or where these conversations are being born and starting to live with network folks, if you will. So if you think about it this way, there's this idea of Terraform being used directly against a network solution. So for instance, there's a Terraform provider for ACI, or there's one for like the Cisco DNA Center and things like that, right? So you could use Terraform potentially to talk to a control plane of, switching gear, if you will, and or the network fabric controller directly. In some cases, that falls in line with this network infrastructure automation use case where there's a decision point. How much of that capability really applies to your day job and your daily walk with your network, right? Are you doing a lot of immutable changes to the network or the fabric? And we're discovering there are certain points in the solution where there is immutability, but by no means is it like this rip and replace. You no longer will ever like console into a switch or anything like that, just being realistic about it. But it's more so the immutable behavior also led to another solution at HashiCorp. So there's Terraform providers themselves. And we've recently created a technology, which is a newer project here called the Console Terraform Sync. And that solution is tapping into our console service mesh or capability, but there's a feature of console known as the service catalog where services register into it and it becomes a source of truth. And that's something we're able to key off of. If a service is spawned and registers into this service catalog, we can then use our CTS solution to trigger action for it to take. And the actions it takes are programmatic behavior that is driven by a Terraform provider. So an example of that would be that one I gave earlier. I'm a Kubernetes user. I launched an application, deployed it, however, into Helm chart, direct deployment, whatever. And an ingress gateway spawns. I need to register its information with ACI and a firewall potentially. Once that service comes online and registers with the console service catalog, we can then set up a job that CTS is listening for and says, oh, I know what to do with you. You're an ingress controller from Kubernetes, so I need to go tell ACI, here's the profile for, based off some tags or whatever, of the type of application you are, here's your network behavior. And there's no ticket involved at that point. It's just programmatically driven by dynamic behavior of services coming up and down, and then actions triggered by Terraform through this integration we have. So it's a little more of a step further in the automation journey, but it's bringing the network experience closer to the application itself and trying to remove human intervention along the way. So that's different than saying, I think some of that comment about the network folks are resistant to things. I think it's more like you can pound sand HashiCorp if you think I'm gonna like stop, managing my fabric and standing up new gear the way I always have, using Terraform now when I don't really gain anything from, automating, the day zero deployment of some gear that never gets really tweaked beyond that or something. You know what I mean?
Gotcha.
So we're more on the consumption of the network by an application side of things is where we're going with it. And so far, there's been a lot of network folks embracing that use case of saying, yes, we agree that last mile network configuration and keeping pace with dynamic workloads that can just, spawn very quickly, expand and contract all that behavior that you just can't keep up with, by a human means. You can't, scale your Kubernetes pod and all of a sudden record 20 new IP addresses on a spreadsheet by a human, or 1,000. Those are the types of things that we're focused on more so than saying you're going to use Terraform to stand up your entire data center. There is some of that, but that's, I think, more like edge locations. If you think of that, like bare metal use cases, there are network components there if you're standing up an edge location and tearing it down and those types of things. But most typical private data centers, the fabric is fairly consistent. So it's more the consumption of the network versus the standing it up day zero type of stuff.
Makes perfect sense.
Yeah.
Cool. Okay. Well, let me do one quick. Nate just said, it seems like a great topic for a future meeting.
It does, actually. So if you'd like to have us back, I'd be happy to introduce you to some of our folks that are definitely more intimate with the CTS solution. But it's a pretty hot topic these days and seems very relevant to the private data center for sure. Yeah,
let's have a conversation after this, and we'll get you on the books for let's see, late August seems to be when we have our next open slot. So we'll make that work.
All right, you put me on the spot on recording too. Yeah,
this is what I do. I get people booked. I get things done.
Awesome. Cool. No, we'd love to. Yep.
Awesome. All right. Well, thanks everybody for coming. Next week we will be continuing our IT career series next Wednesday night. But for now, have a wonderful evening. And Vinnie, thanks for coming by and sharing this with us.
Absolutely. Thank you for having me. Everybody stay safe out there as hopefully the world starts to open up, right? So have a great one. Take care.